Okay, let's look at the last example that we have. Okay, so okay, this is already in the factor. Okay, so which decomposite it. Okay, let's decomposite it. So we have x squared x and this. Okay, so what we have is basically we have quadratic. Okay, we have quadratic, and this quadratic, okay, has been repeated for 2 times. Okay, so it's repeated for 2 times. Okay, it has repeated for 2 times means that, okay, you will have the fraction like this. First of all, the first quadratic, that is x squared plus 1. Okay, and then again the same quadratic, x squared plus 1, but you will have to add power of 2. Okay, will be the same quadratic, this quadratic, this quadratic, but you have to consider starting from power 1 until power 2 because it's repeated for 2 times. Okay, so since that we have quadratic as denominator, means that you're going to have linear as numerator. Okay, so for the first fraction, we're going to begin with a. So linear will be ax plus b. Same thing. It is linear, so you have to continue with the alphabet. So in here, we have to continue with cx plus b. This is also linear. So that is what we get for the general form. Okay. So once we have this, the next thing that we should do is you have to multiply. You have to multiply each of the item. Okay. You have to multiply each of the item with some factors. What is that factors that you need to multiply? That is this. That is whatever at the left, that denominator will become your factors. Okay, that is this one. All right. Okay. So multiply all of them with this x squared plus 1 squared. Okay. So you multiply this fraction at the left hand side. This fraction, you multiply this and this. Basically, they are cancelling each other. So when you're cancelling each other, what will remain at the left hand side will be the top. So we will have x squared plus x plus 1. Okay. So what happened to the right hand side? Okay, this one, let's just write in the bracket first. Let's just write in the bracket first, just so it doesn't confuse you. Okay, so once you multiply this with this, so what happened? This is power 1, the bracket power 1, and this bracket power 2. So you can cancel. So you're remaining of one bracket that is consists of x squared plus 1. Okay, this is the same thing. This is the same thing, but just this power 1, this power 2. So you multiply power of 2 in here. So basically cancel, do remaining of power 1. Okay, same thing happened to the last fraction. Put it in the bracket. So you have cx plus d. Now this cx plus d, this whole fraction, you're going to multiply with this. So if you multiply this whole fraction with this, basically the denominator cancel. So you cancel what you remain. You remain of whatever on the top only. Okay. So usually I will continue to do the comparison, but this one is a bit complicated. Why don't we just expand a bit on this? Okay, so let's just expand a bit on this. Okay, if I expand this, I will have a x power 3, and I will have a x. Okay, expand this, I will have b x squared, and I expand this, I will have plus 1. This one, just leave it that way. I'll have cx plus d. Alright, so we write it in a simpler form such that you will be it will be easier for you to do the comparison of the left hand side and the right hand side. Okay, so let's just do the comparison. So we're going to compare the left and compare the right. Okay, so we'll compare the left and the right. So we're going to do the same thing again. So we're going to something from the highest power that you can see in here. So highest power that you can see, of course, is x power 3. Okay, so that's coming from the right hand side. This is D. Alright, okay. So the highest power that you can see is x power 3. Okay, of course, look at the left hand side. We do not have x power 3. So we are having 0 x power 3. So 0 here. For the right hand side, x power 3 is here. That is a x power 3. This gives you a only. Alright? Okay, then we go for the x squared. For the x squared, so the left hand side we have 1. Okay? 1. For the right hand side, this is the x squared, so we have b. That's all. Okay, for x squared. Okay, so then for the x, we have 1. Okay, how about the right hand side? The right hand side we have here, so that is ax, that is equal to a on b. Okay, the next is cx, it will be plus cx plus c. So that is the next line that you have to do some solving. Okay, you have to do some solving in here. Okay, let's just continue. So we have constant. For the constant, for the left hand side, we have 1 here. And for the right hand side, I did some mistake here. This is supposed to be b, right? Okay, you expand this, you have bx squared. Expand this, you have plus b, sorry. Alright. Okay, so in here, let's just look at the constant for the right hand side. So for the constant of the right hand side, this is actually plus b only. Plus b, okay. And the next constant that you see is d. So we have plus b. So these two equations we can solve, okay. So we already know the value of a. The a is 0. You can sub it here to get your c. So let us do the substitution. Okay, let's just sub the value of a into here. Alright, okay, so sub your value of a equal to 0 into number 1. Right, okay, so you will have 1 equal to 0 plus c. So your c is basically 1. And sub your value of b, into the equation number 2. So we have b equal to 1. Sub it into the equation number 2. So we will have 1 equal to 1 plus b. So d is basically 0. Okay, now take this one, the general form that we have to solve. Alright, okay, so we're going to solve the value that we just get it, okay, from the solving result. Okay, we're going to sub it back here. Okay, to result, what is your value of a? So your value of a, that is 0. So we have 0x. So 0x, of course, we don't have to write it out. Okay, just leave it. Okay, what happens to the value of b? The value of b, that is 1. Alright, so in here, you have 0x plus 1. So that means that you have 1 only. Okay, let's just look at the next. Okay, so next that is you will have cx. So what is your c? So your c is 1. So you have 1x. Okay, so 1x, of course, you just have to write x only. Okay, and what happened to the d? The d that is 0. Okay, so means that you have 1x plus 0. So 1x plus 0, that is equal to 1x only. So 1x, that is x. So that is our final result for the decomposition part. Okay. So once we have obtained this result from the decomposition, okay, and we need to use it back into the integration. Where is my integration? Where's my integration? Let's see here. Alright, okay. Let's say along. Okay. So it's here. Alright, okay. So that is the result of decompositions. Okay, let's just write the result of decompositions into here. So this is equal to this. So we have 1 over x squared plus 1. And this is actually x over x squared plus 1 square dx. Okay, so let's use the result of this decomposition and sub it here. Okay, and I don't need this anymore. Okay, so now, okay, so let's just see, there are things that you can use the direct formula where you can use this one. Okay, this one is you're going to use the formula of the C1, the formula of C1, where you can think of 1 is the 1 squared. This one you can think of is as x squared plus 1 squared. We're going to look at it separately, okay? So this one you're going to use the formula of C1, okay? Formula of C1, okay? How about this? This one you're going to look at it separately also. So we have the x. Alright, okay? So what happened here is, okay, this one you have the direct formula. And from the direct formula, we can recognize what is your A. So your A is 1. So from the formula, it says that you should have 1 over A and arctangent or n inverse x over A. So your A is 1. So this one, we have the direct formula, okay, for doing the integrations. Okay, how about this? This one, does we have any formula for this? Do we have any formula for this? The answer is no, we do not have direct formula for that. Okay, you cannot use the formula of A7 for that. Okay, because the integrations, okay, if you want to use the f prime over m, this is x power 4. Okay, x power 2 bracket x power 2 is x power 4. This is no. Okay, so we do not have the direct formula for doing this. Okay, if that, it means that you need to do another manipulation for that. Okay, what type of manipulation that you need to do? Okay, let me copy this. I need a larger space for that. Okay, let me copy this. Okay, let me push it out a bit. Okay. All right, okay. So, because we do not have direct formula for that, okay, and then what you have to think on is try to do some substitutions. Okay, so try to use some substitutions. Try to sub this one as u. Try to sub this one as u. So you sum, okay, u as x squared plus 1. What happens is you will have du, this one you differentiate, we have 2x dx. Okay, what I need is the form of x dx. So the 2, I have to bring it to the left hand side, so it becomes divided. So I will have du divided by 2. So x dx. So where the x dx, so x dx is basically here. It's x dx. So this x dx you can change it to du over 2. Okay, and just how we say that this one is my u squared, right? Okay, so means that the next line that you see here is actually you will have plus, okay, this is u squared, and this is du over 2, and what we have here, that is 1. All right, okay, so this one you can simplify. If you simplify, you have tangent inverse x only. Okay, this one you can take out the over 2, so we have 1 over 2 at in front, and you have 1 over u square, and 1 over u square you can change it to index, so index is u minus 2, correct? Okay, and integrate it. Okay, it's very easy to integrate this. Okay, this is actually give you, okay, u minus 1 over minus 1. Okay, and simplify it some more, so we have, this one is minus 1 over 2, u minus 1, that is over q. And don't let your answer stop at here, because your answer should be in terms of x, right? So this one you have to change it back. Okay, to trace back where does this u come from. This is actually coming from the substitution. All right, let's change it back. So change it back, so we will have tangent inverse minus 1 over 2. The u here is x squared plus 1 and plus c. Alright, okay, we have done for the lessons of the type number 2, right? Okay, so we're going to stop here. I will see you next class.